Hello world. I'm Imagination. Today I'm going to talk about printing organs. Organ printing utilizes techniques similar to conventional 3D printing where a computer model is fed into a printer that lays down successive layers of plastics or wax until a 3D object is produced. In the case of organ printing, the material being used by the printer is a biocompatible plastic. The biocompatible plastic forms a scaffold that acts as the skeleton for the organ that is being printed. As the plastic is being laid down, it is also seeded with human cells from the patient the organ is being printed for. After printing, the organ is transferred to an incubation chamber to give the cells time to grow. After a sufficient amount of time, the organ is implanted into the patient. The ultimate goal of organ printing is to create organs that can fully integrate into the human body as if they had been there all along. Successful organ printing has the potential to impact several industries. These include organ transplants, pharmaceutical research, and the training of physicians and surgeons. 3D printing for the manufacturing of artificial organs has been a major topic of study in biological engineering. As the rapid manufacturing techniques entailed by 3D printing become increasingly efficient, their applicability in artificial organ synthesis has grown more evident. Some of the primary benefits of 3D printing lie in its capability of mass-producing scaffold structures, as well as the high degree of anatomical precision in scaffold products. This allows for the creation of constructs that more effectively resemble the microstructure of a natural organ or tissue structure. Organ printing using 3D printing can be conducted using a variety of techniques, each of which confers specific advantages that can be suited to particular types of organ production. Printing materials must fit a broad spectrum of criteria, one of the foremost being biocompatibility. The resulting scaffolds formed by 3D printed materials should be physically and chemically appropriate for cell proliferation. Biodegradability is another important factor and ensures that the artificially formed structure can be broken down upon successful transplantation, to be replaced by a completely natural cellular structure. Due to the nature of 3D printing, materials used must be customizable and adaptable, being suited to a wide array of cell types and structural conformations. Materials for 3D printing usually consist of alginate or fibrin polymers that have been integrated with cellular adhesion molecules, which support the physical attachment of cells. Such polymers are specifically designed to maintain structural stability and be receptive to cellular integration. The term bioink has been used as a broad classification of materials that are compatible with 3D bioprinting. Other natural polymers that have been used for tissue and 3D organ printing include chitosan, hydroxyapatite, collagen, and gelatin. Gelatin is a thermosensitive polymer with properties exhibiting excellent wear solubility, biodegradability, biocompatibility, as well as a low immunologic rejection. These qualities are advantageous and result in high acceptance of the 3D bioprinted organ when implanted in vivo. The creation of a complete organ often requires the incorporation of a variety of different cell types, arranged in distinct and patterned ways. One advantage of 3D printed organs, compared to traditional transplants, is the potential to use cells derived from the patient to make the new organ. This significantly decreases the likelihood of transplant rejection and may remove the need for immunosuppressive drugs after transplant, which would reduce the health risks of transplants. However, since it may not always be possible to collect all the needed cell types, it may be necessary to collect adult stem cells or induce pluripotency in collected tissue. Currently, the sole method for treatment for those in organ failure is to await a transplant from a living or recently deceased donor. In the United States alone, there are over 100,000 patients on the organ transplant list waiting for donor organs to become available. Patients on the donor list can wait for days, weeks, months, or even years for a suitable organ to become available. These extensive wait times are due to a shortage of organs as well as the requirement for finding an organ that is suitable for the recipient. An organ is deemed suitable for a patient based on blood type, comparable body size between donor and recipient, the severity of the patient's medical condition, the length of time the patient has been waiting for an organ, patient availability, ability to contact patient, if the patient has an infection, the proximity of the patient to the donor, and the viability time of the donor organ. In the United States, 20 people die every day waiting for organs. 3D organ printing has the potential to remove both these issues. If organs could be printed as soon as there is a need, there would be no shortage. Additionally, seeding printed organs with a patient's own cells would eliminate the need to screen donor organs for compatibility. That's all for today. Thanks for watching.